Hi, my name is Philip Nguyen, and my topic is going to be about chemistry and photography. Let me ask you this. What do you know about photography? Probably a little bit, right? You probably only know how it works and such. Well, then first, you need to understand how many people have access to cameras. 77% of all Americans have a smartphone. America's population is 327 million, and so 77% of that is 252 million people. 252 million people have a smartphone, meaning they all have access to a camera. Imagine all that people, and only like 1% to 5% know how a camera actually functions and know how much work is put into it. Actually, less than 1% really know how a camera works. Back in the early 19th century, the only cameras were the ones made by the inventors. These cameras were extremely hard to create and were possibly dangerous. If you went back in time when cameras were being invented and show your phone or camera to people, they think you're a genius. They will most likely ask you how to make it or how it works, and in reality, you have no clue. And that's what I'm here for. I'm here to educate you guys about photography. Alright, so the idea of photography came from the ancient Greeks. They believed that if a scene or image was shown through a small hole into a dark room, it would be projected into the wall of that room. The thing was, the image was not permanent, and people didn't know how to make it permanent. They called this dark room a camera obscura. During the Renaissance period, perspective became important and made them want permanent images. However, they couldn't make it as though they knew nothing of chemistry. Chemistry really developed during the 18th and 19th century. By early 19th century, inventors were trying to combine the camera with these chemical discoveries. The first person to dive into photography was a man named Claude Niepce, who started his research experiments in 1816. Niepce was obsessed with the idea of making images seen at the back of a camera obscura permanent by means of a support through a compound. A camera obscura is a dark box in which a lens is projected by the images outside into the darkness. The camera obscura was the basis, and images were made by using chemical compounds such as silver salts, regular salt, iron oxide, and manganese black oxide into a paper full of silver nitrate. All of these were to expose the images through the help of light, but it never worked. The pictures Niepce took turned out negative and not visible. Every solution of his turned out to be just tiny little advancements, but only helped the experience little and could not do much to limit the problem. His main problem was the pictures disappearing in the sunlight. Eventually, in 1827, Niepce exposed a pewter plate coated with bitumen and asphalt in the camera obscura for 8 hours and managed to get an image in light and shade. It took him 11 years to get a decent photo for his time. Practical photographic processes were devised in 1830 by Louis Jacques Marie Daguerre in France and by William Henry Fox Talbot in England. Daguerre started to work with Niepce on his concept of photography in 1827. However, Niepce died in 1833, so Daguerre continued the research by himself. One thing Daguerre and Niepce had in common was they both tried to find ways to make exposure time shorter. Niepce's process took 8 hours of exposure, and Daguerre didn't want that. In 1829, he shortened the exposure time from 8 hours to 30 minutes, but it still wasn't enough. In 1835, Daguerre realized he could use mercury vapor to get more of the image to come out. The mercury vapor intensifies the development of the image and makes it much faster, but at the same time the process a lot more dangerous as mercury is toxic. The exposure time became 1 to 2 minutes. Now he solved the long exposure time problem. He had to solve the problem in which silver halide causes the images to become invisible. In 1837, Daguerre realized he could bathe the image into a solution, mainly containing salt, so that the image doesn't disappear. The salt solution washed away the remaining silver iodide. Later, he replaced this process with hyposulfate of soda, or sodium, in which the final product he called daguerreotypes. In 1839, Daguerre brought the daguerreotypes to the French government, in which they became fascinated and released his method to the public for free. So, that's a lot about Daguerre. Now you need to know about William Henry Fox Talbot, or just Talbot. Talbot was an artist who became frustrated over the beautiful scenery he saw in the camera obscura, become nothing but attempts at tracing the picture he saw. Talbot was smart and started experiments in 1834. His process started off with a light paper treated with alternate washes of sodium chloride and silver nitrate. He stabilized his images with potassium iodide or salt, but later switched to hyposulfite of soda or sodium. Talbot's first images were reversed, in which dark areas were light and light areas are turned dark. He realized that all he needed to do was reverse the process, and so he did. His process took 30 seconds of exposure time, and that was faster than the daguerreotypes. Talbot named this process the calotypes. What's even more interesting is that the calotypes could be printed and duplicated, while the daguerreotypes could not. If you realize the actual achievements through the long experiments and time span, it actually was quite long. Niepce took 11 years until he got a stable, somewhat clear, and good image to him. Daguerre took about 12 years until his process was released to the world. And then lastly, Talbot took 6 to 7 years until his process was released into the world. All of them worked in a time period when chemistry was becoming really popular and not all information on certain elements were known. Achievements don't come like that. They take a long time. Daguerre is a great example. It took 12 years for his work to become popular. He started working on photography in 1827, but finally got known in 1839. So every year or every couple of years, new achievements or new advancements in photography was coming. It became a popular thing with people trying to create faster, safer, more clear images, and they did. About 10 years after the calotype and daguerreotypes, printing made it so that photography was so much easier and can be easily duplicated. These are the people who created a topic in which has been constantly been improved. There's not much else to know other than the fact that every couple of years, the previous processes will be improved on and become more popular than the other. I think we should start talking about an advanced version of the old days, modern photography. One of the major ideal things people wanted in photos was color. In 1904, two brothers, Auguste and Louis Lumiere, successfully created a color process they called autochrome Lumiere. The process has started off as autochrome uses a layer of potato starch particles, dyed red, green, and blue, attached to a layer of silver bromide photographic emulsion, all on a plate glass. The glass would be in front of the image and the color would be imprinted into the image. This process was actually expensive and required long exposures. However, they were the best method and one of the first methods, making it truly remarkable at the time. Instant film or photos was introduced by Polaroids in 1948. It delivers photos within minutes through special film. The film consists of a packet that includes film and processing chemicals, and often photographic paper. The processing chemicals include silver bromide, hydroquinone, potassium thiosulfate, and potassium hydroxide. Silver bromide is a crystalline that is light sensitive and captures photos. Hydroquinone reduces silver halide down so that the photo could have color. Potassium thiosulfate acts like a developing agent as it breaks down the silver bromide so that the pictures can stay. Potassium hydroxide speeds up the development so that it doesn't take hours, but minutes. And that's how a Polaroid picture comes out. Instant film is all chemistry. At this point, it's the 21st century, and a lot of technology is around, and there are so many options. A modern camera is built on a lot of chips. These chips are all wired to do a certain function, and they all are micro-sized. Much of these chips are made in the Silicon Valley, the area we live in. Modern cameras also have electronic sensors to measure light intensities and translate them into digital code. Once they are in digital code, you can easily manipulate them on a computer, or check them out. Most professional photographers put their images on a compact flash card in a large digital file format. They can easily access these compared to back then. Looking back at how much chemistry and technology affected photography, you'd be amazed. So much chemistry is used in this simple tool, and maybe someone's everyday life. The process in which taking a photo went from exposing an image in sunlight for 8 hours to get a really dark and not so visible picture to eventually a couple clicks. It took almost 200 years to get where we are now in photography, but I believe it was all worth it. Thank you for listening to my presentation. See ya.